guys, I'm Nisi Poblador. Do you know what quantum physics or quantum mechanics is? If not, I'm here to educate you about quantum mechanics. Let's start. Quantum mechanics is a physical science dealing with the behavior of matter and everything on the scale of atoms and subatomic particles or waves. It also tries to explain the quantum physics or quantum mechanics is a branch of physics that tries to explain the quantum theory. It first started as a bunch of mathematical explanations of experiments that cannot be explained by classical mechanics. Unlike the general theory of relativity that explains motion of things at high speed, the quantum mechanics is not attributed to one person only. It also forms the basis for the contemporary understanding of how very large objects such as stars and galaxies, and cosmological events such as the Big Bang can be analyzed and explained. Quantum mechanics is the foundation of several related disciplines including nanotechnology, condensed matter physics, quantum chemistry, structural biology, particle physics, and electronics. During 1990s, Max Planck, a physicist, explained the distribution of colors emitted over the spectrum in the glow of white-hot objects and red-hot objects. Planck observed that only combination of certain colors are emitted. Somehow, colors were quantized. This was much unexpected because light was understood as a wave. Planck regarded this as nothing more than just a mathematical trick. Quantization helped to explain other mysteries in physics. Einstein published a work where he explained that light is moving not as a wave but as some manner of energy quanta. Einstein suggests that energy quanta can be absorbed or generated only as a whole, specifically when an atom jumps. The energy difference determines the color of the light carried by those quanta when divided by Planck's constant. With this new way to describe light, Einstein offered explanation to the behavior of 9 different phenomena, including Planck's observations. He also explained how certain color of light could eject electrons of metal surfaces. This phenomenon is known as the photoelectric effect. In 1913, Niels Bohr applied Planck's hypothesis of quantization in Rutherford's planetary model of atoms. He postulated his own atomic model which shows that electrons are quantized. Though quantized properties were invented as a mere mathematical trick, they explain so much that they became the founding principle of quantum mechanics. One of the most famous experiments in physics is the double-slit experiment. It demonstrates with unparalleled strangeness that little particles of matter have something of a wave about them, and suggests that the very act of observing a particle has a dramatic effect on its behavior. To start off, imagine a wall with two slits in it. Imagine throwing marbles at the wall. Some will bounce off the wall, but some will travel through the slits. If there's another wall behind the first, the marbles that have traveled through the slits will hit it. If you mark all the spots where a ball has hit the second wall, what do you expect to see? That's right, two strips of marks roughly the same shape as the slit. Now, let's go into the quantum now. Imagine firing electrons at a wall with the two slits, but block one of those slits off for the moment. You'll find that some of the electrons will pass through the open slit and strike the second wall just as marbles would. The spots they arrive at form a strip roughly the same shape as the slit. Now, open the second slit. You'd expect two rectangular strips on the second wall, as with the marbles. But what you actually see is very different. The spots where electrons hit build up to replicate the interference pattern from a wave. Here is an image of a real double-slit experiment with electrons. The individual pictures show the pattern you get on the second wall as more and more electrons are fired. The result is a screffy interference pattern.
How can this be?
One possibility might be that the electrons somehow interfere with each other, so they don't arrive in the same places. They would if they were alone. However, the interference pattern remains even when you fire the electrons one by one, so that they have no chance of interfering. Strangely, each individual electron contributes one dot to an overall pattern that looks like the interference pattern of a wave. Could it be that each electron somehow splits, passes through both slits at once, interferes with itself, and then recombines to meet the second screen as a single localized particle? To find out, you might place a detector by the slits to see which slit an electron passes through. And that's the really bit weird. If you do that, then the pattern on the detector screen turns into the particle pattern of two strips. Somehow, the very act of looking makes sure that the electrons travel like well-behaved little marbles. What does the experiment tell us? It suggests that what we call particles, such as electrons, somehow combine characteristics of particles and characteristics of waves. That's the famous wave-particle duality of quantum mechanics. It also suggests that the act of observing, of measuring a quantum system has a profound effect on the system. The question of exactly how that happens constitutes the measurement problem of a quantum mechanics.